In this lesson, we're going to be solving systems of linear equations with three variables. We're specifically going to be using the linear combination method. Now, I will tell you that this is a very challenging lesson for many students in math. So I want to make sure that you get a very clear understanding of how to solve these problems. Feel free to pause the video at any time so that you can take notes. Feel free to rewind the video so that you can see once again how I did something. Use your textbook as a supplemental aid. All right, so we're going to actually go ahead and get started now. Our first problem is going to be 2x plus 3y plus z equals 9. Oh, and that's an x. X plus 2y minus z equals 12. 4x minus 2y plus 3z equals negative 10. Believe it or not, we actually have to solve this. Normally, you're used to equations that just have an x or a y, or an x and a y. But in this case, we have an x, a y, and a z. So there are a few steps that we're going to take to solve this problem. All right. Step number one, we're actually going to add two of the equations together so that we can eliminate one of the variables. Now, I notice specifically when you look at the very first two equations, here is a positive z and a negative z. So I know if I use the elimination method, they're going to cancel out. So let's rewrite this. I'm going to rewrite the first two equations. All right, so we're going to use the elimination method, adding straight up and down. 2x plus x is 3x. 3y plus 2y is 5y. Z plus negative z is 0. And I was so eager, I canceled it out already. Equals 21. Okay? So now we've gotten rid of the z. Step number two. We're going to add two more equations together so that we can eliminate the same variable. So because we already started eliminating the z, we kind of have to keep eliminating the z, if that makes sense. All right, so let's go with the second and third equation this time. So let's change colors to make it easier for you to see. So if second and third equation, x plus 2y minus z equals 12. And 4x minus 2y plus 3z equals negative 10. Now remember, our goal is to still cancel out the z. So using the elimination method, I need to figure out what can I multiply the first equation by so that my z's cancel out. Remember, you always want them to be opposites. So if this is a 3z, this one must be a negative 3z. There's already a negative here, so I'm going to multiply this entire top equation by positive 3 so that the z's cancel out. All right, so I'm going to multiply the entire top equation by positive 3. All right, so we would have 3x plus 6y minus 3z equals 12. The bottom equation, I'm not going to do anything to it. Okay, so now I set up my two equations here. The z's will definitely cancel out just like we expected. I'm going to add but I'm going to actually write it above because I'm running out of room there. So we'll have 7x plus 4y. Oh, hold on. 3 times 12 is not 12. Make sure you watch those little mistakes, and I just noticed that pretty quickly. So that's 36. And then I copied this one wrong. This is supposed to be negative 10. So you got to watch your mistakes. So something simple as that would have messed you all up. All right, so we have 36 plus negative 10, which is positive 26. All right. So we have 7x plus 4y equals 26. Now we're going to proceed as with the systems that we solved in previous lessons. So I'm going to rewrite the system of equations. So now I have 3x plus 5y equals 21. and I have 7x plus 4y equals 26. So I'm going to solve this like normal, all right? Got a system of equations here. We got to solve it like normal. If you want to cancel out the y's, you have to figure out what number do you multiply these equations by so that the y's are opposite of one another and they cancel out. For example, if I was to multiply the top equation by -4 and the bottom equation by 5, it should cause them to cancel out. I would have -12x minus 20y equals -84. The bottom, 35x plus 20y equals 26 times 5. Now make sure, if you can't do these problems in your head, make sure that you grab your calculator. You don't want to miss simple problems just because you don't have a calculator. All right, so in this case, 5 times 26 is 130. Notice my y's are opposite of one another, so they will definitely cancel out. So I'll have -12 plus 35, and that's going to be 23x. Then we have -84 plus 130, and that's going to be 46. It should be. Now make sure you're checking my math. So we have 23x equals 46. Divide both sides by 23. The 23's cancel out, and I'm left with x equals 2. All right, so we have x equals 2. And you know, we got to find both variables. We got to find the x and the y. So we can't just stop with x equals 2. So you're going to plug that 2 into any one of these two equations here, any one of those two equations. So let's just say I plug it into the top equation. So I would have 3x plus 5y equals 21. 6 plus 5y equals 21. Subtract 6 from both sides. 5y equals 15. Divide both sides by 5. And y equals 3. So now we have our x, we have our y, but don't forget about the z. We got to plug the z back into one of the original equations so that we can figure out what it is. All right, so we got to go back to these original equations up here so that we can figure it out. So let me use the top one. We got 2x plus 3y plus z equals 9. 4 plus 9 plus z equals 9. 13 plus z equals 9. Subtract 13 from both sides. Kind of running out of room here. And z equals -4. Z equals -4. So you have your final answers here. You have x equals 2, y equals 3, and z equals -4. Now remember, you always write your answer as an ordered pair. Always write your answer as an ordered pair. So I'm going to go back up. The only difference now is that we have 3 variables. Still write it as an ordered pair in order of the alphabet. So we're going to have our x, comma, our y, comma, our z. And that would be your final answer. Now, if you remember from a previous lesson, I always told you that the only way that you know for sure that your answer is right is if you plug your answer back into the original problems to check your work. So that means if I go back to all 3 of these original problems in white, then I would have to plug in 2 for x, 3 for y, and -4 for z into all 3 of these to make sure that they checked. If it only checks for 2 out of the 3, that can't be your answer. It has to check for all 3.